Hello, my name is Maciej Cieślak and I am a software engineer at ZBeyond. I'm a part of the development team responsible for our core offering, ePOP Desktop. In this video, I will be presenting how our customers can leverage our software to make meaningful design decisions early on during the concepting phase of their projects. This example, we will look at utilizing ePOP Desktop in the process of designing a hybrid powertrain for a C-segment passenger car. We all know that system level matters. Designers have a hard task of converting the requirements into design concepts. In this study, I will show you how you could use ePOP Desktop to help you in this process. The objective is to determine an ideal motor speed and pick optimal solution from a range of available options. Using ePOP Desktop, we can easily screen the design space using multiple variants of the eMachine. We will also be able to investigate different variants of two-stage transmissions that meet the output requirements. Finally, at the end of the study, we will be able to recommend best architecture solution for the requirements specified. When you open ePOP Desktop, you're greeted with this screen. This is our data library. It stores all the components that are either designed or imported by you from other softwares. The software is delivered with what we call a starter data pack that lets you start your project without any delay. Let's import this data pack. We can see that 162 items were imported into the library. Let's see what they are. We've got 7 different vehicles. We've got 12 different inverters, over 100 motors, and 36 transmissions. If you're interested in the details of each of those components, you can just click on them, and on the right hand side, a description will be shown. Each project starts with a requirements analysis. ePOP has a requirements analysis module. When we open it, we see that there are several steps that we need to take for a requirements analysis to be completed. We will be conducting our analysis on a Volkswagen ID.5 Pro. I'll select it as our vehicle, and I'll set some velocity, torque, and power requirements. This is peak torque at the wheel and peak power at the wheel. When they're set, we can see that the envelope of peak power and peak torque is displayed. If we select a cycle that was loaded into our data library, we can check whether the cycle data is still within the envelope of our requirements. We can look at different tabs. Here we see the vehicle speed versus vehicle acceleration and energies, for example. The next step is power sizing. We do that in the power sizing tab of ePOP Desktop. Power sizing allows us to run a combination analysis of all possible transmission ratios that will meet the design requirements. In our case, when we choose a single speed transmission, we can see that the constant power speed ratio is a little bit high. Therefore, we should use a 2-speed transmission and rerun the combination analysis. We can have a look at what power source coverage have we got and how does it cover our requirements. From this data, we can move on into our proprietary transmission generator, TGen, to generate some 2-stage transmissions. If we go into the data library and into transmissions, we generate new transmissions by clicking New Transmission button. That opens Transmission Generator. We will be looking at 2-stage transmissions, and our input torque will be 240 Newton meters minimum and 720 Newton meters maximum. First stage, we will limit from 5 to 15, and second stage from 3.5 to 10.7. After setting overall ratio targets, we can move on to generating ratios. As you can see, 13 concepts were generated. By clicking Generate Concepts, the software will generate these components and put them into our data library. At the end of this process, we can see that 239 transmissions were generated. In the meantime, I have also limited the set of all the vehicles from 7 to just vehicle of interest, VW ID5 Pro, and I have limited the number of inverters and motors to 79. The next step is to go into study configuration and look at what are the possible combinations of our study that meet our designed requirements. In study configuration, we can see that over 75,000 possibilities were explored. At the same time, by using vehicle filters and limiting our boundary conditions from 180 to 205 maximum kilometers per hour maximum wheel speed and wheel torque from 3400 to 3600 Newton meters, the software has calculated that we have 20 combinations that are meeting these requirements from the architecture set that was calculated from the data library that was generated. Next step is to run a study, and that study will take into account only those 20 successful combinations. As I have ran this study before, I will load in the data that was saved, and you can look at the data that our software calculates using our proprietary post-processing tool called ePOP Viewer. This is our proprietary viewer of the results data. Let's load the results that were just created in ePOP Desktop. The viewer lets us explore the entire design space using a variety of KPIs that can be set by the design engineer. On the right-hand side, we see a scatter plot of the results. Currently, it's showing normalized energy consumption versus powertrain total mass. Of course, these can be changed. For example, let's change it to total cost of ownership in US dollars. And we can see a clear relation between different architecture designs and, well, best optimal solutions. Filters on the left-hand side of the screen allow the users to filter the data further and see which motor has performed the best. In our case, is the motor number 164. To explore any specific point of interest, you can do that by just clicking on it. That opens the point of interest inspector, which lets you see which motor and which transmission were used for that particular architecture. In the point of interest tab, you can view further what data has been calculated in the study. For example, you can look at residency plots for each of the components in the architecture, inverter, motor, and transmission. or at all of them at the system level. Besides residency, you can look at the performance, output torque profile, and other KPIs. So in this study, we have determined that motor 164 is the most optimum one. That finalizes my presentation. I hope it was insightful and showed how easy it is to use ePOP Desktop. If you have any questions, please direct them to our email address shown on the slide. See you in the next one.